Hello, everyone, and welcome to the session.
Hello.
I am going to ensure that we take this discussion to the next level. So let me ensure that I do certain housekeeping tasks before we proceed further. All this while you weren't able to see me, so I thought I'll enable the webcam so that you guys can see me right while I talk. But I've connected on a different machine, which is a GPU machine. While I'm connected on this, I'll be talking from a different machine, and this machine is what I've used primarily to talk. Okay, so let's get started. I'll be periodically peeping into this so that you have a look at who is actually training, right? Who is actually delivering the training for that. Okay. So let's get into this discussion. We started off by talking about how the world is revolutionizing, how the world is moving ahead with a lot of futuristic concepts. Auto machine learning or AutoML is one such field which is, exploiting the field of machine learning and data science. It is automating to a very great extent a lot of tasks which would otherwise requires a lot of patience. You need to keep experimenting with different options. What if someone can automate that? Then would it actually be much better? Sure, right? Absolutely, it would be much better if we can automate the mundane activities, the regular activities, which machine learning expert or a data scientist or an AI expert would otherwise experiment with. And these are a few tasks which can certainly be automated, and AutoML has actually taken this field of data science to the next level, wherein I will show you, when we get into SageMaker Pilot, you need not even write a single line of code. I will also show you on Microsoft Azure ML Studio services that even without writing a single line of code, you can accomplish the entire field, or you can accomplish the entire machine learning algorithm. End to end, you can build it. You can deploy the model in production, and you can start having the end users access your application or access your model that you have built. In the due course, we discuss that. We will understand about TPOT. Okay, and we have already looked at the abbreviation of TPOT. Okay, so, and that is tree-based pipeline optimization tool. We have also understood that TPOT can automate these different steps, which are available in gray box. You have a gray box. All these steps which are listed down in this can be automated by using TPOT. There are a lot of other AutoML libraries and frameworks and tools which exist, which can perform even data cleansing. Like when we look at SageMaker Autopilot, which is from Amazon, you would understand that we can automate even the data cleansing to some extent. We'll get there, but we will first understand how to build a data pipeline automatically. That too, the best pipeline out of all the various pipelines available will hit the best pipeline. How can I automatically do it? After we understand this, I'll show you a few practical ways of making use of TPOT for parallel processing. I'll talk more about that, and then we'll get into feature tools. Once we are done with all of these open source AutoML frameworks or tools, then we shall get into the cloud part of it, and we'll look at how SageMaker, Autopilot, etc. does all of these things automatically. The reason why we are practically looking at the open source tools first is because you'll get a very good understanding on how AutoML tools work behind the scenes. On any of the cloud platform, you will not be able to see what is exactly going behind the scenes, under the hood. What is getting executed? We really don't know. But once we understand TPOT and feature tools, then you'll have a fair bit of understanding on what might be going behind the scenes. Right? So we'll certainly get into the practical stuff of it and discuss more. We also understood that these are the various algorithms that exist. These are all the various supervised learning techniques. These are the various feature pre-processing operations and feature selection techniques which exist. Okay, next. I'm also going to now talk about TPOT a bit, and then we will get into our code part. And we will try to execute the code on Google Colab. All you need is a Gmail account, friends. And if you have Gmail account, just log in and jump in. So we have this complete code available. I'll run step by step and explain everything. But before that, I need to certainly tell you that TPOT is something which is built based on a concept called as genetic programming. I'll go here. I'll probably open a new slide. This time I will use a white screen. Just for change. Maybe you're bored of seeing the black screen, right? That's the reason. So TPOT is built based on something called as GP, which stands for genetic programming. And this GP or genetic programming is something which has emerged from evolutionary algorithm. So GP has emerged from something called as EA. And EA stands for evolutionary algorithm. So you have GP, which is a type of evolutionary algorithm. And TPOT is based on this. TPOT is built on top of this. Right? So what happens in this exactly is something that we need to understand. Okay, and that is why we are trying to do a little bit of deep dive when it comes to TPOT. Okay. So friends, this particular genetic programming has evolved from the field of biology. It was inspired by biological evolution. And it becomes very easy for me to explain certain things because of COVID. Okay, a lot of you all are aware of COVID, and you know that it is caused because of virus. And this virus, what it does is it mutates. There is something called as mutation, right? So I'll talk about that mutation thing in the context of TPOT. Right? So genetic programming primarily has three properties. Property number one is that it has something called as selection. This selection means it has to select the most appropriate algorithm from plethora of algorithms. So it actually contains population of all the possible solutions. It contains population of all possible solutions. Means it tries to experiment with all the possible algorithms with different hyperparameters. Okay. And then based on something called as fitness function, think about this as accuracy. It will look at basically accuracy, and it figures out which algorithm for what options is giving you the best accuracy. Okay. And each of those algorithms are evaluated based on this fitness function. It could be error, it could be loss, or it could be accuracy. Second term that you should be aware of, or second property of genetic algorithm or genetic programming algorithm that you should be aware of is crossover. Crossover is the process of selecting the best solution. Okay, first it will select the best solution among all of these, and then it performs crossover to create a new population and creates new population. So what it actually does is it will try to find out which is the best model for you, and then it will try to create different set of population or different set of algorithms. Say it figured out that regression based techniques is the best. Then now what it does is it will try to look out for different set of algorithms, which will probably give very good result. All right. So this is all about crossover. I'll also give you a different version of crossover. Just bear with me. And the third thing is mutation. What happens in mutation? You take the best solution from the previous point. Say you figure out what is the best solution based on the fitness function. You run different algorithms, machine learning algorithms with different set of hyperparameters, and you figure out that one algorithm has given you the best accuracy. You take that and you try to mutate them, right, by making some random modifications. Okay, you just take the best possible algorithm and just you try to do some random modifications to it and see whether those random modifications are changing anything. Okay, now I'll talk more about this. Just pay a little attention, please. Okay, so these are three properties, right? I'll also give you a different explanation pertaining to this. If this is confusing, I'll give you a different explanation. And in that different explanation, I'm going to talk about three things once again. Okay. One is, of course, you are trying to build all possible machine learning algorithms and associated hyperparameters. Okay, you are going to experiment with a bunch of all the possible machine learning algorithms, and you also keep changing the hyperparameters. Right? First is, this is evolved from what? Biological science. So the first thing is reproduction. With the reproduction, whatever code you have, whatever settings you have, right? If you feel that, hey, this is the algorithm which is the best, these are the hyperparameters which has given you the best accuracy, take that So the entire program or code is copied as is. There is no modification which is done. Whichever is the best model, just take it, use it. Second thing is mutation. Mutation means out of this complete program or code, you randomly try to modify only a portion of the program. So randomly modify only a portion of the program. This is purely from programming standpoint and algorithm standpoint, the explanation that I'm giving now. Third, you have something called as crossover. What you do in this is you take two programs and then you try to take certain portions of these two programs and merge them to make it a new program. You probably take two best performing models, look at the program or the code, take those two, combine them to form a new program. So for example, you take a neural network, okay. Probably you will take decision tree algorithm, you take the hyperparameters of maybe random forest and combine them and see whether now it becomes a good program or not. Or maybe you'll first implement KNN algorithm. On top of that, you might implement decision tree. So you're taking two different programs, two different maybe machine learning algorithms, and you're trying to use some portion from machine learning A, some portion of the code from machine learning B, machine learning algorithm B. You combine them so that it forms a new algorithm, right? So just remember these things, friends. Now we will look at practicals and you'll understand more. You'll understand more once I get into the practical applications part. So let's do a deep dive. First thing is, the moment you open Google Colab, ensure that you go to runtime. You click on change runtime type, select GPU, and then save it. Select GPU and save it. Next, click on connect. You need to click on connect, which is available here. On the right top corner, you have an option called connect. So it is Google is assigning you a computer from cloud. It's just picking some computer, assigning it to you for your work. You can go with the free version, right? Until you experiment and become master at that, you can continue using the free version. And here, we need to first install, okay, TPOT. So here you have TPOT. Just in case you type this, pip install. Let me zoom this a bit so that it's clear for you now. And this exclamation mark is just a syntax. Even without that exclamation mark, this function will work well, right? First of all, you need to go ahead and install TPOT. You all can do it and execute the code alongside me if you wish to. And we can also make available this code to you all on our learning management system, on which you'll also have access to the training slides. You can just go through the slides, you cannot download. But the code part, yes, certainly you can download and start using that. So once you click that, it installs. So let me install it. So it is going and fetching the data from whichever location this TPOT is available in, and it is installed. Okay, please do it along with me, friends. If you feel that if you do alongside me, you're going to learn better, feel free. But anyways, we will give access to the code and the training slides, and these will be placed on a learning management system. Next, you import the library that you installed. What did we install? We installed TPOT. If you want this code, the entire code which was executed, if you want to keep it, keep it. Or if you hover your mouse on that, there is an option to actually clear the output. If you want, clear it. If you don't want, keep it. Okay, choice is yours. Then we are saying import TPOT. Once you import, only then you can use it. So just by installing a library, you cannot start using that. In order to use that, you will have to invoke it. So when you say import TPOT, it will invoke. And if you want to see the version of the library called TPOT, you type TPOT dot underscore underscore version underscore underscore. TPOT dot underscore underscore version underscore underscore. And if I were to run it, it's importing TPOT, by the way, and it shall also give us a version. It's 0.11.7, 0.11.7. Okay. Once you're done with this, TPOT has a lot of options. You have TPOT classifier. We also have TPOT regressor. These are the two things which exist in TPOT. So you can use classifier, or you can use regressor. Right? That is regression. So that is up to you on what you want to actually use. It depends on the business problem that you're trying to solve. And I'm sure you all are aware that if at all you have an output variable which is numeric in nature, you go with TPOT regressor. It's very simple to invoke it. You just need to say from TPOT import TPOT regressor. TPOT. When you do this, you'll be able to invoke. So instead of this, you can type this. If your output variable is continuous or numeric. But if your output variable is categorical, then you need to use TPOT classifier. Okay. Now you can click on this. And what we are doing is we are trying to import TPOT classifier, number one. Number two, we are trying to import from scikit-learn. Scikit-learn or sklearn is machine learning library of Python. Okay, for those of you who are not aware, scikit-learn is machine learning algorithm, machine learning library of Python. That has something called as datasets. From datasets, you try to import load underscore digits. When you try to take load underscore digits, it will load a specific dataset, which is all about identifying handwritten digits. Like you write 0, this is one image, 1 is one image, 2 is another image, 3. In that way, you have 4, 5, 6, 7, 8, 9. You have 10 different numbers. Using these numbers, multiple other numbers are possible. But then, given a handwritten digit, you need to classify, if at all a new handwritten digit is given like this, it should classify that this belongs to a class called 6. It has to automatically do it. So this specific data set, load underscore digits, has access to that specific data set. Right? And how does it look like? Each of this image is of size 28 by 28. So it has 28 rows, 28 columns. And each cell represents a pixel intensity value. Each of these cells represents pixel intensity values. Images have pixels, and each pixel will have a pixel intensity value. And these intensity values range from 0 to 255. 0 means black, 255 means white. So this specific data set contains all these pixel values, and 28 rows, 28 columns. When you multiply that, how much do you get? 784. Am I right or am I wrong? Just let me spend the time and see. I think this is the right number, unless someone wants to, double check that. So now, in the data set, you will have one output variable. Say the first digit is 0. Then this 0 will have 784 pixel values, 1, 2, 3, 4, so on and so forth. How many? X1, X2, X3, X4, so on and so forth. 784 pixel values. And this is the data set that we will get when we run this line of code. Within Google Colab, either you can run one single line of code, or you can run multiple lines of code within one cell. Within one cell, you can either run one line of code, or multiple lines. Okay. Then what we are doing is, after we import that, we are also saying that from scikit-learn, which is machine learning library in Python, from that you are taking something called as model selection. In that you have something called as train test split. Because friends, whenever you have data, of course your data would contain output variables and input variables. Okay. And you cannot say that I'll use the entire data and train it. After you train, how will you tell to your customer that you have built a good model? If you're using the entire data to train, how can you say? You can tell to your customer that, hey, this model is giving you this accuracy. It will give you accuracy of 75% in production. To convince your customer, you need to first of all test the model that you built. The model that you built, you need to test that. Right? So we split the data into first training and test. Randomly we split. Usually it's a random split. So to split this, we are making use of train test split. Now what we are doing is, we imported this digits data set, which has list of all the handwritten digits and the pixel intensity of that. That data set we are loading into another object called digits. You might ask me, why are you doing that? Just because I don't want to work on the same name. If I go wrong somewhere with the data set, I can readily uses load underscore digits rather than working on that directly. Now you're using this train test split, and what you're doing is when you load the digits data set, you'll have two things. You'll have data and you'll have target. Target is your output variable. So this within scikit-learn, the data set that you have already has the data which is segregated as inputs and output. So target is output and data is nothing but bunch of all the inputs. Since the data set in scikit-learn is given in this way, those are the things that we need to use in split. So what we need to do is now you go to this digits in which you store the data. You're saying digits dot data means you're taking only the inputs. Then from this digits, when you say target, only the output variable is being chosen. Then you're splitting the data set as 75% training and another 25% test. So randomly 75% of the data would go into training data set and randomly 25% of data will get into test. Randomly. And you're storing the data in this way, x underscore train. So training data inputs and test data inputs. This also will have inputs. So let me write here. So your training data also has inputs and your test data will also have inputs. Output x1, x2, x3, x4. I mean, of course, in our data set, we have 784 inputs. We also have 784 inputs, right? And then the output variable y for training data, it is stored in an object called y underscore train. And for test data, it is stored as y underscore test. You're just storing the data in appropriate objects. Once you're done with that, you can check what is the dimension or the shape of the data set. X underscore train dot shape will tell you how many rows are there and how many columns. Okay. One more quick thing is, I told you that the handwritten digits, which are used in the digits data set, has 28 by 28, right? That means overall you'll have 784 observations. But here, this is a slightly condensed version of the data set. So for example, this is called as MNIST data set. MNIST data set contains 28 by 28 pixel and it contains all the handwritten digits if you observe here. Okay, and it has 60,000 training images and 10,000 testing images. I can also show you more. On why did not show me? Anyways, so this is a sample data, right? 0, 1, 2, 3 until 9. This is the sample data set. Anyways, the point that I'm trying to drive is this data set that we are using here is a condensed version. You don't have 60,000 training and 10,000 test examples. Instead, you only have 1347 rows and 64 columns in your test data set, training data set inputs. In your test data, you have 450 rows and then you have 64 columns. And when you say output variable shape, it has 1357. So 1, 2, 3, 4 in that way. 1347 observations, and then x1, x2, x3 in that way, 64 inputs. Those are there in this, right? And then in the output, you have 1347, 1, 2, 3, 4, 1347 output values as well. Same is the case with test data also. In test data, you have 450 rows, 1, 2, in that way, you have 450 rows. And then you have 64 different columns. X1, X2, X3, and we have 64. And for each of these observations, you'll have output also. Okay, just that we didn't run that. I can also show you how to run it. Instead, if you just hover your mouse on that, you have an option here. When you click on the plus sign, a new code, line of code, or the cell will appear. Then you can just say y underscore test dot sheet. And if you click on this, it will give you the result. It should give. If it doesn't give me, that means the previous lines of code I haven't run, right? If you run, there'll be a green tick mark. Okay, if you run that particular cell, you'll have a green tick mark against that. Now, if I run it, it will show me the sheet. 450. Yep, absolutely. So you have 450 values here for your output video. Simple. These are the various hyperparameters which are available within TPOT. TPOT classifier, because here the output variable is classified, whether your handwritten digit is 0 or 1 or 2. That's why we use this. But then you also have regressor. Okay, in regressor and in classifier, there are only subtle differences. I'll just explain only that part. Here you have something called as generations. By default, this value is 100. Number of iterations to run. Right? How many iterations you want to run, basically. Then you also have population size. It specifies the number of machine learning algorithms to retain in your population each time you run your entire experiment. How many machine learning algorithms you want to retain? That's what population size is. Then you have offspring rate, mutation rate. 0.9 is the default value, right? It ranges from 0 to 1. Then crossover default value is, this should be equal to, by the way. So let me make an amendment to this. This should be equal to. Okay, 0.1. This value also ranges from 0 to 1. Then you have something called as scoring. Scoring is taken as accuracy. The fitness function that I spoke about is this, right? Scoring. And you have various other parameters. And one very, very important thing, which we'll talk about later, is called as use task. What is this task? We'll talk about it later. Of course, there are a bunch of other options which are available, which I would not be very keen to walk you guys through because. But then a few more things that I need to certainly talk about would be number of jobs. By default, it is 1, friends. This specifies the number of processors to use in parallel. Number of processes that you want to run in parallel. But if this is set to -1, instead of 1, if you put it as -1, you are telling that I want to use all the CPU cores in parallel. That means, I mean, if you have dual core, you can make use of both the cores and TPOT will be running a few algorithms here, a few algorithms in the next code. Core 1, a few algorithms are executed, core 2, a few. If you have quad core, you'll have four cores, which will work in parallel. You also have octa core. These are all the laptops or computers or servers, right? It depends on how many cores you have, but if you want to use all of those in parallel, use this number of jobs equal to -1. And you also have something called as maximum time in minutes. How much time do you want to run your TPOT to figure out the right algorithm? How many experiments should you perform? It depends on maximum time in minutes. If you don't give the maximum time in minutes, it will continuously keep running. And sometimes to experiment all the permutations, combinations, it might also take 1 to 2 hours. Right? So we have the patience to wait for 1, 2, 3, 4 hours. It depends on the speed of your computer also. So here what I've done is do a TPOT classifier, verbosity equal to 2. See, verbosity is also something that you can keep changing. Verbosity equal to 1, verbosity equal to 2, equal to 0, equal to 3, you have various options. Okay? Verbosity value can be 0. 0 means it does not print anything here. That's called a silent execution. It doesn't show you anything. When verbosity equal to 1, it gives you some minimal information that algorithm is completed, running, things of that. When you say 2, it will give you the progress bar. Okay, and it will print more information like generation 1, 2, 3, 4, what is the cross validation score, so on and so forth. Okay, now what are we giving? We are saying that run it for maximum 10 minutes, not more than that, because we need to also complete the experiment, right? And then population size equal to 40. So try out 40 different, pipelines. That is what you're saying by saying that you want the population size to be 40. Number of machine learning algorithms to retain in the population after every generation, right? These are all biological terms. If it's going over your head, forget it. And when it comes to regression, I'll also show you that when it comes to regression model, the only thing that changes is scoring parameter. Here you have given accuracy. When it comes to regression, you're going to give mean squared error or negative mean squared error, something on those. So let me click on run. This line of code, please do not run it. Let me put a hash here. If you put a hash, that means you do not want to run that. Do not run this cell because okay. So what is happening now is TPOT is trying to experiment with all the possible combinations. It will run this algorithm for the next 10 minutes or so, and it will show you on what are the best combinations, right? So you're defining your hyperparameters in this line. If you do not mention any of the other hyperparameters, they're going to assume the default values. To take the default values, and then you're storing your model with these hyperparameters in this. And within Python, When you give the object name and when you say dot fit, it is going to run the model. But to run any machine learning model, you need both inputs and outputs. What does a machine learning algorithm do? If you are given your output and inputs, it will try to learn the patterns. Okay, it will try to learn the patterns between output variable and your input variables. It will try to learn the patterns between output variable and input variables. And then it will capture this relationship using some math equation, some mathematical equation. And this equation varies based on which machine learning algorithm you use. Okay, based on which machine learning algorithm you use, this math equation changes, and this math equation captures the patterns, or you can call it as relationships, between your output variable and input variables. For example, age is say 22 years, gender is male, say income is $10,000, and education is graduation. Then maybe this particular customer A of the bank might default on the loan. Default means they'll take the money and they do not repay to the bank. For second customer, maybe the age is 32, female, $8,000, post-graduation. This person will not default. Maybe this person has repaid the entire loan amount, did not abscond. Okay, so there is a pattern that your model has learned. For example, age 22 years, male, income is $10,000, graduation is education. Highest education is graduation. So people of this kind will default. Your model has learned one pattern. People of this kind might default. Your model has learned the pattern and it has stored that pattern in this math equation. On similar lines, age 32 years, gender is female, salary is $8,000. Say this person is a postgraduate. Then the person has not defaulted. This is a pattern that your model has learned. In this way, based on your observations, rows, it is going to capture, your model is going to capture all the various patterns. And it constructs this math equation, which can then be used for future prediction purpose. And what your TPOT is now doing is, it is trying to run a lot of experiments with a lot of machine learning algorithms. Right? And then it will figure out which is the best model. Okay, now, while this execution happens, there is something else which is called as cross-validation. Let me quickly talk about that also, so that whatever is appearing on the screen or the output, you're at least aware of that. Okay, now, this cross-validation, CE, it's called as cross-validation. Okay, and the most famous algorithm is K-fold cross-validation, in which this K value you need to define. Suppose in your underlying data, suppose that you have an output variable and bunch of inputs. And then you have 1, 2, 3 in that way, 10,000 observations. And say you defined randomly. That is up to you on what you define, friends. What should be the K value is something which is left up to you. The default K value in TPOT is 5. So let me say K equal to 5 because that is the default one. The moment you say K equal to 5, this data set will get divided into 5 different parts. So 1, 2, 3 until 2000, it will be part 1 of your data set. From 2001 until 4000 will be part 2. From 4001 until 6000, it will be part 3. Then from 6001 until 8000 will be part 4. From 8001 until 10,000, you'll have part 5. So total you have 5 parts. Output. Right. You have your output variable and bunch of inputs. And you have all these 5 parts. Part 1, part 2, part 4, and part 5. Okay. Now what happens is your model also will run 5 times. It's called as fold. Fold 1, your model will be trained on part 2, part 3, part 4, and part 5. Meaning, it will take all these observations, all these 8,000 observations, 2,100, 10,000, and then it will train. And then it will be tested. I'll call it as train. Okay, it will be trained on these 5 parts, and it will be tested on part 1 because it is fold 1. And then you'll get some accuracy. In how many of these 2000 observations did your model accurately predict? That would give you some accuracy. Then it will go to fold 2. In fold 2, it is going to train your model on these parts. Part 3, part 4, and part 5. And then it will test on part 2 because fold 2, part 2 is tested. Then for these 2001 until 4000 observations, your model will figure out for how many observations it has given the correct prediction and for how many observations it has given incorrect predictions. Based on that, you'll get accuracy. Then you'll have fold 3. Part 1, part 2, part 4. You're training your model on all these parts and then you're testing it on part 3. So again, 4001 to 6000, you get some predictions and then accuracy based. Then you have fold 4, in which again you have part 1, part 2, part 3, and part 5. You're training the model on these parts and testing it on part 4. Then you have fold 5, wherein your model will train on part 1, part 2, part 3, and part 4. And then it tests on part 5, and then you get the accuracy. In this way, you would have trained your model on all the parts, and you would have tested your model on all the parts. It is done. Okay, model building is done. So what is the message that it says? It has taken 10 minutes, 68 seconds, or 68 microseconds, and then it stopped. So TPOT has closed. And it also says that TPOT may not provide a good pipeline because it was interrupted early. It has prematurely closed, yes. Because 10 minutes was not sufficient for it. If you probably use 30 minutes or 1 hour, Maybe it will try out all the possible combinations and then give you the best pipeline. And see here, what is the best pipeline? It has given the output directly that the best pipeline is, okay, first go with the polynomial features, take the input data and degree 2. Means what? If you have x1, x2, x3, x4, x5, it is saying also include now in your data set x1 square, x2 square, x3 square, x4 square, and x5 square. x1 square, x2 square, x3 square, x4 square, and x5 square. Once you get all these features, apply support vector classifier, linear support vector classifier algorithm. And that would give you the best result. And these are the various hyperparameters. These hyperparameters, when you choose, you get the best model. And this best model is giving you an accuracy of 0.982. Okay. Now what we can do is, I'll just complete this part. It might take slightly more time, but please bear with me on that. If you go to this folder icon and click on this, what would it do? It would mount the Google Drive. Okay, the moment you click on this, it is going to mount the Google Drive. I'll let it mount. It's taking a while. Okay. Ideally, it is going to mount. Don't worry about that. But I also have a line of code, piece of code. If you run these two lines, then also it will mount your drive. So you say from Google Colab, import your drive, means your Google Drive, using which you logged into this Google Colab. Click on this and use drive.mount content. It says connect to drive. It is asking me to authenticate. I'll say allow. That. I mean, that's a very simple authentication process. It's authenticating now and it's going to import. Once it imports, you will see a drive here. The reason why we are mounting the drive is because we want to store this TPOT, okay, best pipeline. Okay. Should come up. Let me refresh this. Yeah, there we go. We have the drive, right? Now, if I run this piece of code, when I say go to this TPOT, you build a model, export it, and give a name TPOT digits pipeline.py. When I run this, it would have extracted the pipeline, and there we go. You have this file now which is appearing. Just double click on that. And then on the right side, you will see the entire pipeline here and all the libraries which have to be imported. Automatically, your TPOT has given you the bunch of libraries and the modules that you need to load. And it has also given you the best pipeline. So just copy these, go here, paste it, and run it. Okay. And go to this best pipeline, copy that, come here, paste it. Oh, sorry. Did I not copy this? I'll copy it. And then I'll paste it. Okay. And then click on run. Your best pipeline is stored. You're not experimenting. You left it to TPOT, and TPOT has experimented various things, given 10 minutes time that you have given to it. And from that 10 minutes, it is figuring out on what is the best pipeline. And this is the best pipeline. You just copy and paste the code here. There is the story. Then you're saying exported underscore pipeline dot underscore final estimator would actually help you get the best model. And you're storing that in an object called best model. Okay. Then you're saying print and show me the best model. It's saying the best model is linear support vector classifier, same thing, which has the C value is so much, dual is false, total equal to 0.5. Friends, every algorithm will have different set of hyperparameters. You should be aware, but in AutoML, even if you're not aware, doesn't matter, it will give you the best result by experimenting. Now, in this piece of code, what I'm trying to do is I'm trying to pick the 11th digit. So you have what in the test data set, I think we have 450 observations, right? In training, 1347 observations. So we are going to digit.images. We are not even splitting it. I'm directly going to this. We stored the data in this, right? Digits. I'm going into that digits. And from that digits, 1, 2, 3, 4, you'll have all the observations. And I'm picking the 11th observation from that. 11th row. In Python, indexing starts from 0. 0, 1, 2, 3 in that way. You're going to the 11th observation. You're taking that digit, okay, and you're trying to display it here. Okay. All you're doing initially is you're creating all zeros. 0 means black, complete black. And you're reshaping it to 1, 64. Then you're taking this 11th digit and you're putting that 11th digit in this ARR. And you're saying plot.figure. Means you want to see what is the digit. And PLT is nothing but matplotlib. Matplotlib is a data visualization library in Python. And then this should be 11 actually. And then what you're saying is, show me that image. Image show. IM show is image show. Show me this 11th row image and plot it using a grayscale here. Color map should be grayscale. Then I also want a text. What should the text be? This is some digit, right? This is percentage d means digit. And in that you want the output variable. Image means inputs. Target means output. And show me the text. Text size should be so much is what you're saying. So if I were to run it, it says that text is this. This is 1. It's also telling here this is 1. This is the actual data. Now what we will do is you import something called as job.lib. Okay. In that you're first importing all the digits from your digits data set. This same line of code we are running. Where is it? This. You're taking the digits data. Okay. And then you're doing train test split. Let me first use this part also. Okay. Here we go. So what we are saying is train test split. Go to this digits data set. Take the data. Data is inputs. Target is output. Ensure that you have maybe 75% in training and another 25% in test. Then this exported pipeline, the best pipeline you store it in exported pipeline. So saying go to exported pipeline and fit the model means run this pipeline. Okay, run this pipeline on your data set. On what data? Training underscore features contain your training underscore features contains You have split the data into training inputs, testing inputs, training output, testing output. So you are having training data wherein you have segregated the target, which is output, and you have segregated the inputs. On similar lines for testing data also, you segregated your output and your inputs. This is for your test data. This is for your training data. Okay, I'm just naming them as training features, inputs. Testing features, test data inputs. Training target, output variable. Testing target, output variable. And then you're saying, build the model, take the best model, fit it on training data inputs and output. Use these two of training data and test. And then you're saying, use my model that we have built and predict on ARR. What is ARR? ARR is the 11th image from the dataset, which is number 1. And then you're saying, store the predicted results in this and print the number is predicted as whatever is that number. Just print that. And then I'll first run it. Let's see what it has to say. It is saying that the number is predicted to be 1. What is the actual number? It is 1. We have just seen that. Your best model that you built is also predicting as 1. And then you can also store this model. Friends, whenever you build your best model, store it so that you can load it and reuse it whenever you want. So here we are saying joblib, that's the library that we imported, .dump, this best model that you built, and save it as digits underscore model.pkl, pickle file. PKL is called as pickle file. Okay, or I think pickle file. So let me run it and then show you what it does. If I go here, look at that. It has saved this also, digits underscore model.pkl. So tomorrow what we will do is, we will load this data set whenever we want and we'll do the predictions. Right? So this is how you make use of your TPOT library and get the best pipeline out. It is just a matter of double clicking on this. And the moment you double click, you get to see all the libraries that you need and the best pipeline. We looked at what is the actual data. It is showing us 1 for 1 observation, 1 row. And then when we predicted, then also it was saying it is 1. That means you built a good model. We just tested for our experience, right? For our knowledge. Okay, so I shall stop now. I request you all to please kindly look at your chat window. Please kindly look at your chat window. And then we will also post questions on LinkedIn. Okay, so you will have to answer that question. On LinkedIn, we are going to post a poll question. It is very simple. Just go there, look at the multiple choice and select the right option. This way you will be learning. Okay, it is very important for you to understand the specific poll question. And I would recommend our team to post that in the chat window so that everyone can answer that. Just a minute while I ask our team. Okay, so you got the poll question, please answer that. And thank you so much. Tomorrow when we connect, we'll take this discussion to the next level. These are all very advanced techniques and amazing techniques to learn. You can truly impress your interviewers, and also you can fast track your projects, right? You can do your projects in a much better manner. Thank you all so much. And sorry, I exceeded the time of 1 hour, but hope you all have enjoyed it. Thank you all. please have an eye on the chat window. That is going to help you guys a lot. Thank you all.